This is second semester, 7th grade math, Unit 4, Lesson 8. Tomorrow we have a quiz. Vocabulary review. When you translate a point, what do you call the new point? Who can volunteer to give me the answer? Kalila. Prime has more to do with the notation, and it's specific to an individual point. But who can help Kalila out? She's kind of on the right track, but that's not what I'm looking for. Lola?
The image.
The image. Very good. Okay. Now, I color-coded these translations. Do you guys remember that's what we worked on yesterday? So yesterday, we started talking about transformations, and there's more than one type transformation. So the first one we learned about is a translation. Okay, today we're going to learn about another one. So these are all different translations, 2, 3, and 4, and they want us to translate point 1, 3. So let me go ahead and put point 1, 3 on the board, and I'm going to put that up in black. Okay, I know I had you guys come up last time. I want to make sure I get this on the message board, so I'm going to go ahead and put this up. P13, remember 1 corresponds with what direction? The x direction. And because it's positive, which direction do we go?
Right.
To the right. So I'm going to go positive 1. And the second number is what?
Y.
The y direction, right? And it's a positive 3, so which way am I going to go? Up 3. So 1, 2, 3. So here's P. And the coordinate, I'm not going to label it because you can see what it is up here. What I'd like for you to do, can somebody tell me the coordinate of my first translation? Who can tell me the coordinate? Quinn. What's for? No, for P primed. My image. What's that going to be? Right, so it's going to be -3 for my x-coordinate. And then what about the y? It's going to stay the same because you see that y doesn't change. So if I go this way, 1, 2, 3, 4, that's my new point. And that is P primed, the image of P. And that coordinate is -3. And then my y stayed the same, so it was 3. Okay, any questions? This is our review. Are we good? Yep.
Last time on the homework, it was asking us to do this, but it didn't say bracket, so should we have put like more than one apostrophe?
If they didn't want you to graph, but remember, you can't say P again. You're saying the new P, and the way we do that when we're talking about transformations, we put an apostrophe and we say P primed. Got it? Okay. So, question.
Even if it's two different, like, let's say it's not 1 and 3, it's 1 and 3, and then another one, you wouldn't do 2 P's. Like, if it's 1 and 3, you do translation, and there's another.
So here, let me get that resolved right now. The reason why I'm using 2 primes here is because we're graphing on the same graph, and I want to differentiate between the two. So I'm differentiating by that by having a green color, but notation-wise, we need to say, hey, we got another transformation. What's that? We should still need to name it as P prime. That's the image. Okay? Trinity?
How many apostrophes are you going to put for?
It just depends. For here, I had 3, so that's why I had 3 primes. They're all on the same graph. Okay, but Trinity, can you tell me what my new point for P is going to be for the third transformation, or for problem number 3? What's my translation going to be? 1, 5. So if you notice, my x value stays the same. So I'm staying in the same spot. But my y value increases by 2. So you're going to go up 2. And so we have our new point, P double primed. And that's this point right here. And that point is 1, 5, like Trinity just said. Are we good? Okay. Who can tell me, did they observe something about number 4 and how it relates to problem 2 and 3? What'd you see? How are the first 2 related to the last one? Nathan?
So they combined it for both.
Nice. And I like what you use. It's like they combined 2 and 3 together to make 4. Nathan, can you give me the answer for 4? Nice. It's going to be -3 because my rule for x is subtract 4. Okay? And then it says add 2. So that means my point's going to be over here, and I'll call that point P. And I'm going to use triple prime just because it's different than the other points. And that is going to be -3, -3. And let me go ahead and graph that point. That point is right here. Okay, we good? Okay, so this is a recap of error. Oh, my bad, that's 5. There you go. Let me fix that. All right. Jason. It's just a different translation. I already used prime, so I can't use it again. That's another one. Got it? I can't use prime or double prime, so I use triple prime. That's it. Let's not get wrapped up in that because we got to get to the reflections. Now, can I get somebody to read through this really quickly? Aday, read through that, please. Stop right here. After you read this. What's that? Once you read this, you can go. What's that? Okay. Well, we're not going to have a power struggle today, so you can choose. Another volunteer? Taylor, can you read this, please?
What you'll learn. To identify lines of symmetry, graph reflections, vocabulary, line symmetry, line of symmetry, reflection, line of reflection. Why learn this? Symmetry is often seen in nature. A snowflake forms when water vapor freezes. Most snowflakes have line symmetry and rotational symmetry. The red line drawn on the snowflake divides it in half, and the two halves are mirror images of each other.
Okay, let's pause for 1 second. So we're talking about line symmetry, but that's really kind of an intro into what we're going to use today to graph our new transformation, which is a reflection. So we use a line of reflection to kind of figure out where is my transformation going to be if I reflect this about this line. So before we get to that, let's take a look at this snowflake, okay? There's already one line of symmetry here. And basically what that says is if you had this in front of you on a piece of paper and you folded that piece of paper along that line, everything would line up. They would meet up. This point would meet up with this point here. Everything would line up just nicely. Do you guys understand? Now here's my question for you. Is there more than one line of symmetry here?
Yes.
Okay. Adepoju, can you do me a favor? Can you grab the red, and draw another line of symmetry? Nice. Is there another one you see? Good. Perfect. Very good. Have a seat. Okay, so Adepoju is correct. He drew 2 more lines of symmetry. That's the one that most people picked out today. Is there some more lines of symmetry is there a line of symmetry that we can add to that? Yes. Jameson? Can you do me a favor, Jameson? Can you pick up green and draw another line of symmetry? And draw it straight across, not just through the little part, all the way across, a nice long line. And then the other way too, yes. Very good, nice. Perfect. So if we fold it across the horizontal line of symmetry, everything lines up, right? Good. Does anybody see another one? There's some more. Most people got this far and stopped. I'm going to go ahead and draw the others. Here's the others. Right? I could fold it that way. Here's the other one. I could fold it this way. Okay. Now, you're going to have a quiz question like this. You'll have a test question like this. So here's what I need you to do. If we're counting the lines of symmetry, you have to be careful because this is where I've seen students mess up in the past. Do not count the same line of symmetry twice. Got it? So if it helps, draw it out. This is my first line of symmetry. 1, 2, 3, 4, 5, 6. Do you see why I stopped at 6? Because if I went to this line up here, what would that, didn't I already count that line? Yeah. So we have 6 lines of symmetry. There are only 6. I already counted that line down here. I don't want to count the same line. Kalila.
Testing on paper and the quiz. So we can
That's not important right now. Right now, we're going to get through this. It might be, it might not be. Now, the other thing that I don't like that the lesson brought up, rotational symmetry. Now, that's something that's coming up later. That's not the point of this lesson, but I will briefly tell you what rotational symmetry is. Rotational symmetry, I'll get to your question in a second. Rotational symmetry says that, hey, if I rotate my image, can I rotate it in a way that it looks like it started? Can I rotate this snowflake in a way that I started out with what I end up with what I started with? Yeah. Right. Can you describe that rotation using degrees? Can I get a volunteer to describe that rotation in degrees? Jayla. Now, 90 degrees, let's try it. If you notice, this is pointing up top. Did I rotate it 90 degrees? Does it look like it started? Can you give me one that will make it look like it started? 180. So if I rotate it 180 degrees, now it looks like what I started out with, right? Somebody earlier said 360 degrees. Now, this isn't the focus of this lesson, so I don't like that they brought this up. I just wanted to mention what that is. If I rotated 360 degrees, that would do one full rotation. It would take me back to the start. Just know what that is. We're going to get to that transformation later, okay? Now, I had a couple questions. Before I proceed, can you continue reading this part right here? And then I'll answer your question if you have a question still.
A figure has line symmetry if a line called a line of symmetry can be drawn through so that one side is a mirrored image of the other. If we can fold along the red line of symmetry drawn on the snowflake, the right side of the snowflake fits exactly onto the left side.
Okay, very good. What was your question? Okay, so let's take a look at my example problem. How many lines of symmetry? So I wouldn't mind getting a volunteer to come up and draw one line of symmetry. Okay, but before I do, I thought I had some other questions. Who else has some questions for me? Okay. Any questions? Okay. Olu, can you draw a line of symmetry for me? And can you use a color? Don't use black. Use a color for your line of symmetry.
Can I go to the bathroom after this?
Mm-hmm. Who said no? He's right. Okay, good. Okay. No, that's good. You're good. You're good. Put it down. Go ahead and sign. Where's the sign-out sheet? Okay, you guys know how it is. Shh. Quiet, please. Hey, that's no one person's responsibility. That's the whole class's responsibility. And you know why we have that in place. Excuse me, why are we talking over here? Now, that's one line of symmetry. Does somebody have another line of symmetry? Lola, can you draw another line of symmetry? No? You don't have another one? Quinn, can you draw another line of symmetry, please? All the way across, not just... There you go. Continue. All the way across. Good. Very good. All right. There's another one. Can you guys guess how many lines of symmetry there are? I heard 6. I'm seeing 2. No, there's more than 2. Adipoji, how many you think? 3? That's a good guess. That's not right, though.
1.
Look. If you notice, quiet, please. Take a look. I want to kind of use what... Oh, excuse me. I'm talking. I don't know why people are talking. I want to use what Olu started out with and what Quinn started out with. I noticed when you guys drew it, you started in between the petals and you drew a cross, right? Started in between the petals, you drew a cross. Let's continue that. Look. Okay. Okay. Did I get them all?
No.
Got one more. Okay. Let's go ahead and count them up. And remember, be very careful on this. I see people mess up on this all the time, and on a multiple choice question, I promise you they're going to give you double. And that's going to be one of the answers, and you're going to feel good about it because you didn't count it right. That's 1, 2, 3, 4, 5. Am I going to count that one?
No.
Why not? I already counted it, so it's 5 lines of symmetry. Are you good? Okay. Who knows what this is? Totem pole. Actually, you find this in the Northwest. Totem poles, and you also find tikis in Hawaii, right? Isn't that a type of totem pole? Yeah. How many lines of symmetry? 1. Very good. Which direction is the line of symmetry? Straight up and down. Very good. Here we go. Boom. 1 line of symmetry. Excellent. Now, let's get into the transformation we're going to learn today. Okay? So, a reflection is a transformation that flips a figure over a line called the line of reflection. Okay? So, I still want you to think about it this way. The line of reflection is still like the line of symmetry. That's where we're going to fold it to line up our points. Got it? So, for this one, we're going to start out with A at 3, -2. So, let me go ahead and graph A. And it says +3, so I go which direction on the x-axis? Right. So I'm going to go 1, 2, 3. And then -2 for the y value, which direction do I go? I drop 2 levels, 1, 2. Now, it wants us to reflect this across the y-axis. Can you reflect A across the y-axis? Can you do that? On your own. When you're done, put your pencils down. Point A, we're going to reflect it across the y-axis. Nope, I don't know what you guys do with your clipboard. So between now and your next period, during transition time, somebody needs to go find it. So who can tell me if I'm reflecting this across the y-axis, and I'm going to highlight the y-axis. So this is similar to my line of symmetry. I'm reflecting it across the y-axis, so mentally what you should be thinking is, if I fold across the y-axis, where is my image going to be? Can somebody give me the coordinate of my image? Somebody I haven't heard from yet. Henry. You said 3 and 2. So at +3 and 2. So if I folded it this way, did they line up? What kind of reflection did he just give me? He gave me a reflection across the x-axis, so we don't want that one. But I'll keep that answer for your next one because that was for the next one. So that would be correct for this one, 3, 2. But that's not what we want for this one. So for the next example, that's the reflection across the x-axis. Henry, can you fix it so we can get the reflection across the y-axis? Any idea? Do you want some help? Okay. Joshua, can you help him out? Very good. -3. 1, 2, 3, and -2. 1, 2. Nice. Here's what I need you to do now. Go ahead and label the primes and the double prime. And I need you to come up with the arrow notation for those two transformations. Okay, remember we did the arrow notation yesterday for the translations? Now we need to try to figure it out for, remember arrow notation? Any point, what's the output going to be? You need to come up with your algebraic expression to represent your x-coordinate and your y-coordinate. But just like yesterday, I said, hey, write your original point coordinates and your image's coordinates. So I'm going to go ahead and put these in, and I'm going to color code these. So A, we saw, is already 3 and -2. And then over here, we already named A prime, the image. Instead of 3, it was -3 and -2. So, taking a look at that one, what would be my arrow notation? Kayla, you got a guess? What would be my rule for any point that I want to reflect sideways on the y-axis? So remember how we did this yesterday? We tried to figure out, okay, what changed, and how do I make an adjustment for that change in my expression so that it works for any point? Is there anything that didn't change? What did not change? The y. So if we think about this and take a look at the whiteboard, and I'll put this on the smart board here in a second. You just said the y didn't change, right? Okay, so that part of my rule doesn't need to be adjusted, but something happened to my x value, right? It became negative. And how do we show that algebraically? If I want to turn something to the different sign, but the same magnitude. So the number stays the same, but the sign changes. Right? I'll give you an example. Two numbers that have the same magnitude are negative 15 and positive 15. Right? Adipoju, can you help her out? Beautiful. Multiply by what? Negative 1, right? Doesn't negative 1 change the sign, but not the amount, the distance from the reflection, the line reflection? So the way we write that is just like this. Nice. You guys were the first class to actually get that in the first round. I had to kind of help the other students out a little bit to get there. So using arrow notation, here's what we got. This is what we started out with. We know that the x changes, but the y does not, and the x changes by a factor of negative 1. Okay? So a couple questions. Question?
How come in the second graph it's double prime instead of
We're talking about a different transformation. Okay, whenever we change the transformation, you can rename it. It's just a name. It's like, why did I call the variable x? Why did I call the variable y? I don't want to use y again if I'm already using it in the same problem, and I'm talking about different variable. That's all it is. It's just, you guys are getting caught up on just the name of something. Well, if I was on the same graph, I wouldn't use the same one, but I could have on a different graph. You could, fifth prime, as long as it's obvious that you're talking about a new translation. Yep. You had a question, Olu? I'm out of seats up front. Okay, who's got, first of all, this point didn't change, right? So my a is not any different over here. But my a prime, what's the value of my a prime? A double primed, excuse me. What are the numbers here? What's my x coordinate? 3. What's my y coordinate?
2.
Positive 2, very good. So can you guys come up with the rule for that? Think about the rule for the last one, reflected across the y-axis. I haven't heard from Nicholas today. Nicholas, do you have a guess? Nice. So it's almost the same, right? So it's going to be x comma y, arrow notation, and x stayed the same, but for y, we multiply that by negative 1. Now, can I share with you another rule that the other classes came up with that I thought was pretty creative? They said, a couple students said instead of multiplying by negative 1, they said divide by negative 1. Is that true? Mm-hmm. If I divide a number by negative 1, does that get us what we want? What's 6 divided by negative 1? Negative 6, right? So what about negative 6 divided by negative 1?
6.
Positive 6. So you see how that works too? Okay. Something some of the other students did also for y, like in this first example when we flip it reflected across the y-axis, for the y coordinate, they had plus 0. Y plus 0. Does that change it? So that worked. Or somebody else put 1y. Would 1y change it? 1 times y, would that change it? Okay. So there's a couple ways we can write this. Are we good? Quinn, do you have a question?
I was asking, you could have add 4 plus negative 2, right?
No. 4 plus negative 2? No, because if we add, it doesn't work for every point. Like, I'll give you an example. Some students were trying to say as a rule for a to a prime, they said, oh, I'm just going to subtract 6. But would that work for 5, 0? If I subtracted 6 for 5, 0, would that work? So let me give you this point. I'll give you this point, and I'll call it C. C is 5, 0. If I subtract 6 from that, will that work? What's that going to put me at? That's going to put me at -1, and that's not a -1, 0, and that's not a reflection. Do you guys understand? So I'm trying to get you guys to come up with a rule that's going to work for every single point. So now that you've seen that example, here's what I need you guys to do. This one we're reflecting across the y-axis. This one we're reflecting across the x-axis. Except for now we got a different point. This point is -4, 1. Can somebody tell me which quadrant this point P is going to be in? Who can tell me which quadrant? You guys forgot about quadrants already?
Yes.
Tori, which quadrant is point P going to be in?
Is going to be in quadrant 2.
Very good. So this is quadrant 1. Quadrant 2 is where you're going to have a -4 and a +1. And remember, quadrant 1, 2, 3, 4, it goes counterclockwise. Very good. Now, we are reflecting this across the x or y-axis. Can somebody share with the class what P prime is going to be? Who's got that? Nicole, you got a guess on that? If I was to fold this along the y-axis, where would my new P be at? So it lines up with my old P. Where would my image of P be? You said -1 and 1? You said -4 and what? And -1? Can you make an adjustment? Now that you see it, maybe I'm trying to see if this will help you out. I think what you're trying to think of is, I think what you're thinking of is up and down reflection. Okay, this line is side to side. So where should my P prime be at? Dominic, can you help her out? Nice. So Dominic's correct. It's at 4 and 1, +1. So do you see now, if I was to fold this, how those 2 points would line up? They're the same distance to the line of reflection. Okay, so what's the rule for this one? Who's got the rule for that one? Somebody please give it to me. When we reflect it across the y-axis, who's got it? Henry, you got it? What is the rule? For any x or y, what do I get back? What am I doing to my coordinates? Very good. Did I change levels? Y has to do with up and down. Did I change levels? What's that? X times -1. So my y stayed the same. It's my x value that I multiply by -1. Okay, who's got the reflection across the x-axis? Who's got that? So P is right here. It's at -4 and 1. Now, Nicole, this is what you were thinking about earlier, this reflection, up and down. And so you're correct. So if you look at this rule and see what changed over here, What do you think the rule is for this one? Can you piece it together? Can somebody help her out? Trinity? And then I'm multiplying the y by -1. Okay, so Nicole, do you see how these two are they're similar, but the one that I'm changing is the one I'm multiplying to -1. Do you understand? Are we good? Any questions about this? Okay, moving along. Here's what I need you to do. Here we have a triangle. Points A, B, and C. What I need you to figure out is, what is my triangle going to look like, the image of the triangle going to look like if we reflect it across the y-axis? That's the first one. Let's do that one first. Somebody tell me where point A prime is going to be at. Kalila. -1 and 4. Well, that's where A is. So I'll go ahead and label A. You said -1 and 4, but can you tell me what A prime is going to be? The new A? And we'll put that in blue. We're reflecting this across the y-axis. So you're saying 4, -1? Okay. Once you see it, that's why I'm trying to show it to you. Where's it going to be at? I think you might have switched some things around, some coordinates. -1, -4. That's not across the y-axis. That's across the x-axis. So can you give me the point for it across the... You gave me the point across the x-axis. I need the point across the y-axis. -4 and 1, that's here. That's not going to be it. So we're flipping it sideways. Maybe that helps. Can somebody help her out? What's that? Nice. 1 and 4. Okay. Who can give me B? Jameson, can you give me B? Nice. 4 and 2. Very good. And who can give me C? Unisa, can you give me C? I haven't heard from you yet.
2 and 1.
Very good. 2 and 1. Now, just so you can visually see what's going on, I took and here is my triangle formed by these 4 vertices. Do you guys see that? Isn't that the mirror image flipped over, right? Got it? Now what we need to do is we need to flip this image across the x-axis. So it's an up and down reflection. Can somebody give me some points? Are there any questions before I move on to the x reflection across the x-axis? Question?
When you're flipping it across whatever axis, like if you put it in the y, does that mean that the y will stay the same?
Let's go ahead and draw. I like your question. Let's go ahead and draw the arrow notation for it. So x, y, arrow notation, and then what's my rule for that? What didn't change?
Y.
The y, because it stayed on the same level, right? So my y value stays the same, but what changed? The x. And how did it change? It changed signs, or we multiply by -1. Okay. Oops. All right. So can I get a volunteer to tell me what is the coordinate for point A if I reflect it across the x-axis? Who's got that? Karis, can you give it a shot? I haven't heard from you today. If I'm reflecting it up and down, where is A going to be?
1, 4.
So 1, 4 is here, but we want to flip it up and down, right? So you said 1, -4. That puts me over here. There we go. Okay. Remember, the negative direction for x is left, and then down is -4. Okay. Can I get you to do b for me? What's the image of b? Okay. Nice. Perfect. Good. Joshua, can you tell me what C is going to be? Waters. Very good. -2, and then we drop 1. Now, if you notice, here is the triangle formed by those vertices, and you see visually it's a reflection up and down, right? Right? Are we good? Okay, any questions now? Yes.
On the quiz, is there going to be a question where it asks you to reflect it over the y and then use that reflection and reflect it over x?
They could ask you that way. They say, hey, I want you to transform it across the x and then the y. They can. That's the more challenging ones will be like that. Okay? So you have to be able to comprehend what the question's asking you. So I'm just trying to get you guys to do one transformation, a reflection across one of the axes. Okay? Okay, but you're right. They might do what's called a compound transformation. Let's just say do this, then this. Okay? Now, what is the rule for this one? Do you guys remember? What's the rule for it? What is the arrow notation for this? If I start out with any x or y, what's it going to be? The y is multiplied by -1. What about the x? X stays the same. Nice. Okay, end of the lesson. How is a line of reflection like a line of symmetry? Think about that. I was trying to get you guys ready for this in some of the wording I used. Joshua. I like that because I like that you're saying the line of reflection splits it in half, or the line of symmetry splits it in half. So you're sort of on the right track. Let's see if we can add something to that. Olu. Okay, you're kind of on the right track too. I'm gonna give you a hint in a minute. Let me see if Khalila's got it. No, we're not talking about rotation. We're just talking about our reflections. Kayla.
Whatever axis would be the symmetry because it's going to be the same on both sides.
What do you mean by same?
Like, it's going to
'Cause-
equal on both sides.
What do you mean by equal? You're really close. What do you mean by equal? Can I give you my hint now? Can I give you my hint now?
No.
Jameson, can you help out?
When you reflect it, when you're doing a reflection, you're just taking it and it's going on the other side. It's going to give you exact, it's going to pretty much like a mirror image.
Nathan?
So, like, when you flip it onto the other side, it's like you're flipping it over.
Can I give you my hint now? Look, watch my hint. Look at this. Look at this.
No, I said it first. I said it first.
You just changed it. You're just moving the opposite
What am I talking about here? I heard it. The same width, distance. The distance. Okay, now I'm going to talk you through it. Some of you guys gave me the pieces there. Listen. Shh. For a line of reflection or a line of symmetry, points are the same distance to that line. Got it? So, how is a line of reflection like a line of symmetry? Points are equal, distant opposite direction. From the line of symmetry and the line of reflection. Okay, now this threw some students off throughout the day, so what I'm going to tell you to do, draw this equilateral triangle on your paper. First, you got to know what the definition is. What's an equilateral triangle? Somebody? Moyen, what's an equilateral triangle?
A triangle where all sides are
All the sides are congruent. So draw that. Triangle with all the sides about the same. Try to make it as close as you can. All the sides have the same. And we had another word for this. What happens when we have all same sides, same angles? For any polygon that has all the same congruent sides, congruent angles, what is that? No, it begins with the R. Who's got it? Same sides and same angles. Go ahead, Anissa. There you go. Did you guys hear that? Regular polygon. So we're gonna draw a regular polygon that's a triangle, and there's a special name for that. It's an equilateral triangle. So who can tell me how many lines of symmetry there are? Not one. More than that. There's 3.
You said more than 3.
No, somebody said 1. It was more than 1. So 1, 2, and 3 lines of symmetry. So 3. Okay, look, you guys should know this. I kicked this dead horse to death. Look, what's the arrow notation for this reflection?
The y-axis.
What is arrow notation? What is the rule? I need you to raise your hand, and I'm going to call on one person. Who can share with me their rule? Lola, what's the rule going to be for this reflection? For any point x and y, what's the rule to get my new x and y? What am I going to divide by -1? The x. So the x coordinate, you're going to divide that by -1. That's correct. Because if I have this c, it's -5, right? Yeah. If I divide -5 by -1, what's that going to be? +5, right? Another way we could have written that was multiply by -1. The y doesn't change. It stays the same. And then the final question, triangle ABC is reflected over what axis? Somebody, anybody? The y-axis. Okay, before we leave, because some of you need to practice, we need to name these points. What is B? B, name that the coordinates. No, look. Raise your hand, please don't call out. Shh, Henry, give me B. Your name's not Henry, you shouldn't be talking. I'm just wanting to hear Henry, and he's way in the back of the room. I don't want to hear anybody speaking but Henry right now. Henry, go ahead. -3 and 4. Now, Henry, can you give me the value for the image of B? What is it? 3, 4. Very good. And then can I get a volunteer to tell me the coordinate for A? Who's got A? Somebody tell me that. Talise, what is the value, what's the coordinate for A? What is that? 1, 1 would be this. So you gave me the value of the image for A, which is 1, 1. But what's the original A going to be? Shh, quiet, please. 1 is here. Negative what? -1, and then +1. And last but not least, C. Who can give me C? Who's got C? Quinn, go ahead. What is it? Hurry up.
It's 5 and
5.
negative 5 and 2.
-5 and 2, that's up here. That would be up here. -2, very good. Shh, quiet, please. Quiet. And then what's the image of C? Quickly, Quinn, what's the image of C?
The image of C is 5 and -2.
Very good. Ladies and gentlemen, you have a quiz tomorrow.